Okay, trig, it all begins with a circle. And so you say, what circle? And I say, it doesn't matter. Any circle that you want. Does it look like a circle, by the way? I mean, it's not like, it's not an oval or an ellipse. It's a circle. Okay, we want it to look like a circle. So it's all going to start with this. Well, let me say this. What is trig about? This is what trig is about, in a nutshell. It's about measuring stuff related to a circle using the radius. All in all, that's what it is. So let's write that down. Trig is about yes, the top hat question for Wednesday. Measuring quantities relative to a circle or related to a circle using the radius. That's it. That's it in a nutshell. Okay? And so let's be more specific. Okay? Measuring quantities related to a circle using the radius of the circle as the unit of measure. So let's look at the radius here. So here's the radius. Okay, there's the radius. So the first thing I'm going to do is I'm going to take that radius and I'm going to peel it off and I'm going to lay it on the circle. Did you see that? Let me do it again. It's so cool. Okay? I'm going to take the radius and I'm going to take it off its normal spot and I'm going to wrap it on the circle. I'm going to preserve its length. That's one radius length. Okay, so if I were to oh, you gotta see this though. Oh. He was Donald Duck for Halloween. Okay. Kids are slightly better than math. Okay. All right, here we go. So what we're going to do is we're going to look at three. I told you that we're measuring quantities related to a circle using the radius. Okay? So there's three I want to look at here. Purple, arc length. Okay? We want to measure that arc length with the radius. And then red. So that arc length took us to a spot on the circle. So for that spot, I want to measure the vertical distance above the horizontal diameter using the radius length. And then thirdly, the blue. I want to measure the horizontal distance of that resulting point on the arc length to the right of the vertical diameter. Okay, so we're going to start by estimating all those things. So looking at this arc length, and I've given you this tick mark to show you what one radius length was. What do you estimate the total purple arc now is measuring in terms of the units of the radius? What would you estimate? A half? 2? 10? 0.1? Okay, so I heard some people say 1 1/4. 1 point. You should be thinking like 1 1/4, 1.25. Is that what you were thinking? Yes, that's a good estimate. It's like 1 and like 1/4 more. So if I'm measuring that arc length in terms of the radius, it'd be like 1.25. Okay, still using the radius length for this resulting point right now. What would you estimate the vertical distance of that point is above the horizontal diameter? Now again, you're using the radius as your measuring stick, or as your unit. What would you tell the person next to you? What would you estimate that this red length is, the vertical distance of that point above the horizontal diameter, measuring it in the unit of the radius? Is it 1/2? Is it 2? Is it 10? Is it 0.1? What would you say? And then, while you're talking, this one as well. So what would you say? This blue length, the horizontal distance to the right of the vertical diameter on the circle. If you were measuring it in the terms of the radius length, what would you estimate? So talk about those two. So these two right here. Talk about it. Okay, how about the vertical distance? What'd you guys say for your estimate? I heard 0.7. What do we think of that? 0.9. 0.91. 0.95. Okay, I had 0.9. If you're in the ballpark of 0.9 or 0.95, almost 1, right? It's almost 1 full radius length. Okay, how about the blue one? Horizontal distance to the right. Okay, 1/4 or something like this. 0.25. Okay, so this is the idea. This is the idea of getting started here, measuring things in the circle using the radius as your unit of measure. Okay, now I'm going to tell you that the radius of this circle is 40 centimeters. You see that right there? The radius of the circle is 40 centimeters, and I'm going to tell you, so let's just put little wavy bars here, just to remember, these are estimates. These are estimates. But now I'm going to tell you that that actual distance right there is 52 centimeters. And I'm going to tell you that that actual red height to the point is truly 38.4 centimeters. And the blue distance to the right, let's say, so the red one's up, right? The red one's up, 38.4 centimeters up. And then the blue one to the right is truly 10.8 centimeters. Okay? Now, based on that, now I want you to tell me exactly, compute exactly each of these three things using the radius as a unit of measure. So I want you to get exact results now for the arc length, the vertical distance, and that horizontal distance measured in units of the radius. Go, work together. So now we're doing our estimates now exactly. Okay, so if the radius is 40 and that's 52 centimeters, then how would you measure how long that is in terms of the radius? So you want to know how many what? How many 40s are in 52, right? You want to know how many 40 are in 52. How many? 1.3. You're going to take 52 over 40 and you're going to get 1.3. So that's 1.3 radius lengths, that arc length. Okay? Vertical distance. So if it's 38.4 centimeters, we want to know how many 40s make up 38.4, right? What do? Should have gotten 0.96. Did you get 0.96? Or we're asking what fraction is 38.4 of 40? That's how many radius lengths up that point is from the horizontal diameter. Okay, finally, horizontal distance. Did you get 0.27? Okay, so these three measurements that you just found, 1.3, who knows what that is relative to trig? 1.3 is measuring what? Does anyone know? That is the angle measure. It's the angle measure of from the horizontal diameter up to that point. This angle measure right here is 1.3 radians. That angle measure is 1.3 radians. It's how many radius lengths the rays cut off. How many radius lengths of arc length the rays cut off. That's that angle in radians. Super important. Okay, so 1.3 radians is the number same as the number of radius lengths cut off by the rays of the angle. Okay, what about this? This 0.96. Measuring the vertical height of your resulting point on the circle in the units of the radius is, does anyone know? That's what sine theta is. That's what sine theta is. It's measuring vertical height of your resulting point using the radius length to do it. So right now the sine is 0.96. It's almost one full radius length because it's almost to the top. And then measuring the horizontal distance. Well, that's easy now, right? Okay, so where does angle measure in radians come from? The number of radius lengths that the rays cut off. First of all, if you start from the 3 o'clock position or the right side of the circle, that sweeping that many radians gives you a point on the circle. Now, how high that point or how low that point is, measured with the radius, is called sine of theta. And how far to the left or right that point is, using the radius length, that's called cosine theta. Okay, so let's do it again here. Now the radius instead of 40 centimeters is 0.2 miles. 0.2 miles. Okay, so I will tell you that this is 0.26 miles. That red length is 0.192 miles. And the blue length is 0.054 miles. So what I want you to do is estimate the angle theta and compute it. Estimate the value of sine theta and compute it. Estimate cosine theta and compute it. So the estimations, no calculator, you're just by looking, okay? You're going to do your estimates, and then after you do your estimates, then you're going to, given these new distances in miles, and that the radius is 0.2 miles, then you're going to compute theta, sine theta, and cosine theta exactly. Work together. Go. Okay, what was your estimate for theta? What's your estimate for theta? 1.25? That was the same estimate we had before. But I gave you a different circle. Should it be the same? Why should it be the same? I gave you a new circle, right? A much, much, much bigger circle, right? The last one had 40 centimeters. This was 0.2 miles. So why is the estimate the same?
The ratio between the radius and the arc length is the same.
Okay.
Circles are proportionate to each other.
Okay. Those are two things. Why? So why is it really? Why are they the same? Yeah.
You didn't change the radians up. All you did was change up the units of distance.
Okay, we're still not getting to the heart of why it's the same. What is 1.25 a measurement of? Where did the measurement for the angle come from? How many radius lengths, right? What is trig all about? Measuring quantities related to a circle using the radius of the circle as a unit of measure. So I gave you a much bigger circle. What did that mean for the radius? It's much bigger too, right? And so if you use the radius of this new, much bigger circle, you're going to get the same number of radius lengths if I don't change, this place on the circle. If I don't sweep a different angle, okay, it's going to be the same number of radius lengths. And then similarly, that vertical distance, the same. Okay, so your estimates were the same because we're using radius length to measure, and when we made the circle bigger, the radius got that same amount bigger. It's the same proportion bigger. And so then your calculation should have yielded the same thing too. So the point is this angle measure in radians, sine and cosine, they're universal. It's not just about, so you may have learned in the past, it's just about the thing called the unit circle, right? Circle centered at the origin, radius 1. Well, think about it in terms of, it's for every circle. Sine and cosine are the same for every circle. Thinking about using the radius as your measuring stick. Using the radius, one radius length is your measuring stick, no matter what size circle you have. Okay? So let's try a different example here. Change it up. Okay, so, and I'll write this out here. So I want you to estimate theta, sine theta, and cosine theta. Go. Theta, sine theta, and cosine theta. For this situation, it's a new situation now. Okay, he asked, what's the radius? What's the radius? I want you to estimate theta, sine theta, and cosine theta. What's the radius? Did anyone understand what I just said? What's the radius? It doesn't matter. The radius could be 0.1 millimeters, or it could be 1 billion miles. Your estimates will be exactly the same. Why? Because these things are measured in terms of the length of the radius of that circle. It doesn't matter if this is a millimeter or 1 billion miles. Your estimates should be the same. Does that? This is the key. This is the key. You're measuring using the radius length for the circle you're on. Go. Estimate. Theta, sine theta, and cosine theta. Okay, what'd you estimate for theta? About half of a radius length. You should have seen that that's about half of a radius length. Okay? Sine theta. Okay, so you're looking at, I'll kind of drag a little bit. What fraction of a radius is that right there? What would you estimate? A little bit less than a half, right? You see a little bit less than a half? That distance is not quite half a radius length. So what do we say? 0.45 or something like that. Halfway between 0.4 and 0.5. Cosine theta. Some are saying 0.8. That's decent. 0.85 is decent. I'll say 0.85. Maybe a little bit more than 4/5 of the way, right? 0.85. Does that make sense? All right, let's try a related rates problem using these ideas, okay? So if, now, before we do that, if this is the circle of radius 0.2 miles, then how would you find how many miles this point is, say, to the right? So I want to know, how, from this vertical diameter, how many miles to the right am I if the radius is now 0.2? What would you do? It should make sense. What you would do now to find how many miles that point is to the right of that vertical diameter. Is that a matter? Yeah. Okay, what am I going to do with that? So I've got 0.85 as my cosine and my radius is 0.2 miles, so what would you do? 0.85 divided by 0.2. Okay, we got multiply too. Which is it? Divide or multiply? This is 0.85 radius lengths, right? It's like the fraction of the radius length that we're over here. So don't we want that same fraction of 0.2 miles to get miles? Multiply or divide? Multiply. This is 0.2 miles, so we want 0.85. We want 85% of 0.2. We want 85% of 0.2. You got to see that that's multiplied. 0.85, so it's going to be 0.2 cosine theta would give us that in miles. So it's like taking a fraction 0.85 of 0.2. So find out. So we're expecting something a little bit less than 0.2, right? Or 85% of it. Anyone got that real quick? What is it? 0.17 miles. That sounds about right. Okay, 0.17 miles to the right. Okay, let's, I'm going to look at, does that make sense? Does that make sense? Okay, so let's look at example here. So motorboat leaves the shore going 28 kilometers per hour in a circular arc with a radius of 60 meters. How fast is the boat